I see that it's already 2 o'clock, so let's start, okay? Hi everyone, my name is Julius and I'm the founder and CEO of CloudWiser that is hosting today's workshop. We also have Klaus here who will be delivering the workshop itself. Klaus, do you want to say hi to the audience?
Good afternoon, everybody. I guess that's my hi.
Thanks, Klaus. And I'm very happy to have all of you joining this event, and I hope you'll find it interesting and useful. And before we begin, let me just go over some details on how we will be proceeding. We have training accounts ready for you if you would like to do the activities of the workshop yourself, and just drop us an email to events@cloudwiser.eu, and we'll send over the credentials. Maybe it's still there's still some time for you to get ready, so just hurry up and then you can catch up. Your questions, of course, are very welcome. Please submit them in the Q&A section that you should see in the bottom. We will go through them during the workshop if there's time, and after the main part is done at the very beginning, just to get we'll try and get all of the questions answered. And this event is being recorded, and we'll share the recording with everyone tomorrow by email. And that's about it from the logistics and then the details part. And I have a few slides ready for like doing an intro on the Spot platform itself. But as we discussed with Klaus today about the workflow of the workshop, we saw that at the beginning we'll have like a 10-minute gap while the cluster will be going up. So we thought that maybe we'll go over those slides at that gap, and then I think we can start with the workshop. Klaus, are you ready to take over?
Yep, that I am. All right, so now that you're not sharing, I can put on the presentation. Right, so let's start with who am I? I'm working as the head of infrastructure at Nordigen. Nordigen is a fintech company working with categorization and basically parsing and analysis of financial data. I've been working as a DevOps engineer for most of my career, and as a result also with AWS and the other big three clouds. Right, so what we're going to be doing today is mostly working with Amazon EKS and Spot Ocean. Amazon EKS is Amazon's version of managed Kubernetes that basically alleviates you the management of the masters and allows you to just worry about the worker nodes. And Spot Ocean is Spot's version of alleviating the need for even managing the worker nodes. Right, and the reason why is because, well, cost is one of the primary things when you're running with Spot Ocean. You're not running normal EC2 instances. Instead, you're running them through Spot. Also, another thing is scaling. You simply do not have to worry about it. You set up the intentional limits to the cluster, and then the rest of the management of performance basically goes through your pod settings, because the rest will be simply handled by Ocean. It on the fly basically picks up instances as you need them and scales down as well, while also managing the Spot cost allocation, so none of the instances ever go down. That way, they also can ensure that your uptime is, or rather, the SLA is the same as Amazon's, as if you were running on standard EC2 instances. And the third thing is speed, and that is in the context of scaling, because if you've ever dealt with AWS auto scaling, it can be at times slow, meaning that the reaction times for new instances to spin up takes quite a while. And in the case of Spot instances through Ocean, they can afford to bring up more instances quicker, simply because it's not such a cost burden overall on the system. Right, and over the course of the workshop, we'll go over basically 3 basic stages. And in the first one, we'll be setting up a basic EKS cluster and set up some example applications on it and put basic auto scaling on it in the context of Kubernetes auto scaling. So it auto scales the various pods depending on the resource usage. Then we'll be connecting the actual cluster to Spot Ocean, and then going over some advanced capabilities and manual control that you have over the way that the instances are scaled, managed, and etc. Right, so I guess that's enough for the boring slideshow part, and let's get on to the gritty part. Right, before we go with that, I'll share a link to the GitHub where all the code is hosted. Once I manage to not fail at Zoom. Right, there, that's the GitHub for today's workshop. It contains pretty much everything that we'll be going over, and also some example, also the code for the example applications. Right. We can give you a couple of minutes to pull that. As for the requested part, I think everybody should have already set up their working environment. If somebody doesn't have that yet who's following through, then I guess just post a message and then we can wait a bit. And meanwhile, I'll start with the terminal. Right, so the main 3, or well, I guess in some extent 4 tools that we'll be using is AWS CLI. That's mainly for authentication for the sub tools, because EKS CTL and everything else basically goes through it. Then EKS CTL, which is Amazon's CLI specifically for managing EKS, that will be used for actually starting up the cluster. Then there's also the AWS IAM authenticator, which is just basically glue that allows you not to bother with the IAM settings and authentication between the apps. And last but not least is kubectl, which is the basic Kubernetes CTL management tool. Right, if nobody's having any issues with that, then I guess we can start with actually creating the cluster. That is fairly simple. You simply run EKS-CTL to create cluster. We specify the version of Kubernetes that we want to run. The latest, I'm pretty sure, is 1.17. which is not actually the latest version of Kubernetes, but it's the latest version that EKS supports. We add a name to the cluster, specify the amount of nodes that we're going to be using, and then we specify the AMI usage. In this case, we can just leave it to auto, and then we specify the region, which in this case, I'll be using EU West 1. Now, this is the part that basically creates a bit of a downtime because, as I mentioned earlier, it takes a while for EC2 instances to start up. So if you've gotten that far, it will great success, but this is where we'll be stuck for a while. And while this is going on, maybe you can take over for a bit, Julius.
Yeah, sure, Klaus. Like I said, I have a few slides. I had a few slides ready for the intro, so we'll just go through them from maybe a bit more from the business side, and then the history of spot instances, as they were called. I would like to add to that this is also a very good moment to ask any general questions regarding like spot instance. I see, at least from the attendees list, that there are a few people that should be quite familiar with Spot platform. So if you have any questions, just shoot them in the Q&A session, and then maybe we'll use this gap also to answer those questions or have that discussion. Okay, then let me share the screen as well. Good. So for those who do not know CloudWiser yet, so we're an advanced tier AWS partner that is operating in the Baltic countries. So that means Lithuania, Latvia, and Estonia. And our friendship with the Spot platform came kind of naturally, as we were seeing AWS users that were using Spot, recommending it to everyone, and being actually like super happy about using it. And that was quite convincing for us to try it out ourselves. And it didn't take much time as for us to become big fans of Spot ourselves. And we actually have it's set up for a number of our customers. And actually we decided that this kind of like platform and technology just needs to be spread even broader. And that's how the idea of this event was born. And if you look at the history of Spot or Spot-Inst, I think most of you know this name even better, because they were called Spot-Inst just until the beginning of this year. Like Spot-Inst was born from the idea that there's a need for a tool to easily run stuff on AWS on the Spot instances. And I don't know if everyone here is familiar with Spot instances and what it is, but basically those are like the same EC2 instances that you're most probably running every day. There's two basic differences there. One is the price. It's usually around 3 times or even more cheaper than the regular on-demand EC2 instances. And the other part is that the tricky part is actually that those instances could be taken from you with a 2-minute notice. It's not that it's happening all the time, but you have to prepare your architecture and your application to be able to handle that. And Spot saw that opportunity and then just built a platform to solve that. So at the very beginning, once they started helping the customers and they built the tool, first of all, of course, with I would say quite limited functionality, but the basic part is still there. So when they started cost optimizing the customers' workloads by empowering them to utilize the Spot instances quite easily, and don't forget that when they started, AWS from their side had a lot less tools that are working with Spot instances. So their business started growing like crazy. They were adding other cloud providers, so you see that they're now they're working with all the three top clouds, building integrations to new products, expanding the team, and I've seen their numbers in a few presentations. So it seems like, yeah, you know, they were growing just like any other very fast and big and very successful startup. And tried funding, and finally they got acquired by NetApp this summer. So that's why, if you've seen the logo in our workshop invitation, so it says Spot by NetApp. And a funny story is that you know, some of the biggest product teams inside NetApp were actually using Spot for quite a while and extensively. So I guess it should have been quite an easy decision for them to buy Spot. And once, you know, next to the overall growth, they were building new products, and now there's a few of them. But Ocean, our main topic for today's workshop, is the most popular one, the most successful one. And it's basically built on top of the same idea of running stuff on Spot instances, just enhanced with you know, additional integration and orchestration for containerized environments. And today, Klaus will be like going through the Ocean part quite deeply, just for you to see how it works and how it runs. And hopefully you'll be very pleasantly surprised and with what you see, like the same as the team of CloudWiser was when we tested it out or configured it for a few of our customers. So that's about it. I have one more slide regarding the pricing for closing the workshop. Maybe let's see if we have any questions. Yeah, I have one from Laurinas. Klaus, do you see it? I can read it out loud to everybody. It's what are the advantages of using Spot platform compared to AWS EC2 Spot offer? Yeah, which is the standard one.
Yeah, so basically, first of all, as Julius already mentioned, that's a really new thing. And from AWS side, like that showed up only this year from AWS. But I would say one of the advantages is actually you still get deep insights from Ocean. It is simpler from management side, because with AWS, if you're using their Spot offering, you still have to manage all the scaling parts fairly intensely, and there's quite a fair bit more involved configuration process from AWS side. Meanwhile, Spot running Spot's Ocean is pretty much simply going once through a dashboard and you're done, which is kind of the cool part. I mean, if you're at the end of the day, if you're setting up identical environments, the AWS Spot offering might end up being slightly cheaper, but that comes with the cost of your time and less features, because also with Spot you get various instance management types. Then again, that also appeared in AWS, but One of the other bigger benefits I would say is the automation aspect, because Spot directly integrates with both Ansible and Terraform, and I'm fairly sure some other automation tools as well, but those are the main ones that I've used with them.
I can add to that also that, if I guess, we need to agree on what we're comparing, because if we're comparing Ocean as a product, so yeah, then most probably we need to compare it with like AWS ECS or EKS or even Fargate services. Yeah, Klaus, correct me if I'm wrong. So on that side, I totally agree that those are different products, and some of them have Spot instances integrated into them, some of them not. But yeah, that's then it's a matter of taste. Though a lot of our customers, I would say, they like Ocean a lot better than the standard stuff from AWS. On the other side, if we're looking at the like what Spot calls like Elastic Group, which is like just the basic service of just running and scaling Spot Spot instances. So without like it doesn't have to be like containers or anything like that. So on that side, Spot has a few quite nice parts. So one of them is that they're actually constantly monitoring the whole market and availability of Spot instances, because if like AWS takes your Spot instances not because they want it. It's just that if some customer paying on demand would like to get, they have a lack of on-demand instances, they simply take that from the Spot instances, and then you're forced to live without it. So what they're doing, they're monitoring all the availability zones, different regions, and etc. As they have like massive amounts of customers, and they can query that, and they have some machine learning models. So what Spot actually is saying is that they are shutting down your instance and spinning up a new one, even before AWS actually says to you that they want to take the instance. They want to just be ahead of that, and that's one of the cool things that which you are not getting from AWS at the moment.
Actually, fun fact, that is something, well, of sorts that AWS is now offering. They also have this for auto scaling groups, like you can actually use Spot instances, and they will do some form of management, but I would say mainly it's just speed. Again, the speed at which Ocean swaps it out is a fair bit better, simply because of this recognition software, I guess, that they're running. At least that's from my basic experience.
Okay. So Klaus, do we still need to wait for the cluster to come up?
Yep, the cluster is still raising. It does take a good while to start up.
Yeah, this time. Maybe there are some other additional questions from the audience. Yeah, and thanks, Laurinas, for this one.
And if anybody is having any issues, like getting to this part or anything, then feel free to speak up, and we can help you get through it. Because there's like 13 people that should be also doing it on their side.
Yeah. Oh, I see a question from Rivis. Does Spot drain instances before shutting it down?
Yes, that's the way they ensure the uptime, and also why they do it beforehand, before they actually need to do it due to AWS. So they drain them and there's no downtime. Basically, they time it so it happens the time when you need to have been shut down is already a fair bit after your new instances are already spun up.
Yeah, we have a troubleshooting message in the chat from
Yeah,
last time.
looking at that. Client timeout. Huh. Haven't actually experienced that. What happens? What happens if you run it again? There's a GitHub issue on exactly this problem from the looks of it. Might be simply, which region are you using? The same EU West one? That's an interesting one. Good thing the main stack is still not up yet, so we do have time to try and troubleshoot this. Are you running uh, the commands through Docker or something like that, or it's running on your instance, your machine directly? Honestly, I'm not really sure what's causing that. Like we can maybe go afterwards through it, and after the workshop can check with you and try to figure it out afterwards, if that works, since the main cluster is up. So maybe we can continue for now, because honestly, I'm not sure what the problem might be there. Like, internet seems to suggest that it might be some kind of a networking problem, but don't know.
Yeah, then if we have everything ready for going on with the workshop, then yeah, maybe let's go ahead, and then we can follow up afterwards or during the process.
Okay. Right. So now that we have the cluster up, kubectl should be working as well right now. Like, we can test it. Like, we can see that there's nothing really up right now, but kubectl is up and running, and that means that we can actually start looking at deploying our applications, right? If you've downloaded the Git repo, you should be able to go to it. And I actually need to pull it. Aha, fun fact. I did not pull the updated version in the Linux machine. Right, so we should have the basic layout, and the sample application consists of 3 parts. It's a front end and 2 different backend applications. The idea being that the front end connects to both backends and constantly refreshes itself and shows the basic shows the IDs of the machines that it's running on, or well, in this case, the pods. And that's simply to show which AZs it's on and how the scaling is working and such. Right, so deploying the application is fairly simple. All the manifests are in there, so it's basically as simple as running kubectl, specifying that we're using a file, and going to each of the applications. So first there's the Node.js, and it's Node.js backend YAML. We actually have to apply it. That changed it. Right, so kubectl apply in the other order. I think this is a Monday. Right, sorry about that. And we can do the same for the other applications. So the second one is the Crystal backend, and the last one is the actual front end. Now, if we want to see what's going on, we can get the pods, and now we should be able to see that there's actually the 3 basic pods, and the front end one is taking a little bit longer to actually start up, but that's not a problem, because the front end app also includes a dependency on a load balancer, because that's the entry point. And if we want to see more details about the individual deployments, we can simply run get deployment and the deployment name. So for example, front end. And then we can see more or less the same data, just specifics to the deployment. Right. Now, if we want to actually see the application, we can run kubectl and get service frontend. This should output the whole details about it. And the most important part, the external IP, which at this point is the load balancer that's handled on the AWS side. And we can already open that link. Actually, let me move to sharing that whole window. Right, and in the background we can see right now, since there's only one replica, you can see that the reply is constantly from a single instance. And as you can see, it's constantly refreshing as well, and that's intentional. So now that we have the actual applications ready, the next part is actually getting some form of auto scaling in Kubernetes working. For that, we need to install a metrics server on the cluster itself, because by default, Kubernetes is not really exposing any kind of metrics. But luckily, that's simple enough. We can simply apply, again, an application, which in this case pulls directly from GitHub. You can check the manifest. And it fairly quickly adds the metrics server. Now we should actually be able to see metrics, like with which are not yet available because it also takes a moment. Because of course it does. Which I think it shouldn't actually at this point, but it is actually responding, right? So sometimes it's an issue that it takes a while for the metrics to aggregate for the first time when you're actually deploying the metrics server, but that's okay. In a short while, it should probably be working. But in the meantime, we can actually set up the...
Klaus,
Yep.
could you please make the screen larger? There's a
Oh.
request from the audience.
Yeah, sorry about that. Right, I'll move back to sharing just the terminal. That should make it more readable. Is it okay now?
It's full screen. Thanks a lot.
Yeah, scaling and scaling windows while sharing is not always that great. Sorry about that. Right. So if you didn't see, like before, here we can see. Let's make it bigger. When you're requesting basically the metrics server runs on the still called beta API. That's mainly because it's Kubernetes. Everything about it is kind of beta. But it's the first API version for the metrics one. There's a second one that has come out recently that exposes more data and thus allows you to set scaling policies on even more advanced in dependencies and information, but that I think appears in Kubernetes 1.18, and EKS specifically doesn't support that yet. So we'll have to do with version 1, which mainly supports things like CPU metrics, which for Docker and most applications is not the worst, but for some more advanced scaling policies, you would want to get more detailed options. But for the context of the workshop, we're sticking with CPU metrics. So maybe now, yeah, there we go. Now we can see the actual CPU usage and memory usage for our 3 different pods. Right, so back to setting up the scaling. You can set that in 2 different ways. Like for most cases, you most likely want to set up a similar scaling manifest, which is kind of the same as the manifest for the application itself. But in this case, since we're just showing examples of it, we'll use the CLI version of it, which is super basic. In this case, for each specific one, we run kubectl auto scale. We specified that we're targeting deployment and specifically, e.g., the front-end deployment. Then we specify on what metrics we're going to be scaling. And so simply to show for the scaling to be quicker, we set it to a low value of 50%. And then we specify the minimum amount of instances that we want to be running and the maximum, which can be any arbitrary number, say 30. Boom. And we have that, and we should be immediately be able to check it by running kubectl get HBA. And here again, at first, we get the unknown, but that's not an indication that it's not working. It's simply that, again, it takes a moment to aggregate the data. In the meantime, we can do the same for the other 2 applications. So for the Node.js backend and for the Crystal backend. And again, if we run kubectl get HBA, oh, we can already see that we're getting some load on the front end, which is mainly because this is constantly open and refreshing. So it's actually adding some load, and we can already see that the front end is scaling. And if we get pods, we can now see that there's already 3 different front-end instances. And that's basically auto-scaling already working, but specifically on the side of Kubernetes. Right. And you can see in the application how it's constantly swapping between the instances. That's mainly happening for the front end and less for the back end, mainly because the backend applications don't create that much of a load. But if we open more tabs, over time the backends would also start scaling. Right. So that's basically the basics of scaling. For now, we can close the open application so it naturally scales back down. And then is the side of the Spot. All right. If you signed up for Spot previously, you should have been able to connect the two account, connect your trial account to the workshop AWS account. Then on the first login, you will have a prompt asking you to connect the two accounts, where you'll basically have to run a CloudFormation stack. In this case, this one is already connected. So the next part is connecting the ocean. For that, we go on the left side. We probably could use zooming. We go on the left-hand side, there's the ocean option, and select cloud clusters and create. Here you can already see like the different kind of backends that they support. In this case, we're gonna be joining an existing one, so it's migrate worker nodes configuration. Here, yeah, then on the next stage, you have to select the first location, which is a bit weird user interface, but that's the case anyways. Once you specify location, you can then select the workshop and fill out the cluster name. Just use the same one that you used before. And that's it for the basic config. And here comes the more interesting specification. I guess that's a bit too zoomed in. All right, so you can make all the changes to the network configuration, like what VPC it's using, what subnets it's using, what images it uses for starting up the instances, security groups, and all that kind of configuration. When you're importing it, it automatically imports also the config that already exists. So it is basically the working configuration. It adds also some spot-specific configurations, specifically tags, on basis which Spot identifies the instances. And you can also configure various resource limits, which there's two halves. First is at the very top, there's machine types, where here you have the selection of all the instance types that can be used. You can unselect any, and also limit the type of instances that are going to be used. This is the first part is specifically for instance limitations, so you can limit it to not use abnormally large instances, at which case it's if you're gonna need scale, it's gonna just scale more horizontally and not vertically, which depends. Like you can easily leave it to just use any instances, because it's not gonna be using instances that are too big for the current load at any point, really. Or rather, after a short startup period, because at first it's gonna over provision, but over time, as it learns the actual usage of the apps, it's gonna scale down the baseline, so it's not gonna be using the bigger instances that much. And then on the bottom, it's the global resource limit. So not per instance, but rather how much the cluster can scale as such. And in this case, the defaults are fairly large, but we can lower it to a more reasonable number of just 1,000 cores. And same for memory, which is still a fairly large number, since 2 terabytes of memory should be enough. You can also do some additional configuring for draining timeouts, volume size, and that kind of stuff. But for the context of the workshop, that's not really necessary. And then this is the main part, how you connect the Spot to your cluster. You pretty much install a simple script into your cluster, which brings up another API layer into the cluster. So, and that is what provides both the management aspect and information to Ocean regarding how big the cluster is, what are the usage, and how it needs to scale. And that's what it also learns from. And to do this, you simply copy this either to a shell script, which is what I've done, or you can just run it in your terminal, obviously without the shell bash. And just generate a token. In my case, that's already generated, and I've saved it to a file simply so I don't have to show on the recording the actual tokens. We can then run it. As you can see, it imports the config map, creates the service account, and some basic role-based access control configurations. Now, from the get-go, the connectivity will not start instantly, but it takes around 2 minutes, after which you can test the connectivity, and it works. You can then get a summary where you can reconfigure some things if you need to, like naming or tags, and then just run the creation, which
Klaus,
Yep.
as we have like a moment, there's a question from Arnold in the chat regarding the IAM authenticator step. Could you maybe answer that one quickly?
Yeah, looking at that. And that's basically your AWS configuration, and you can input it either through running AWS CLI configure, I think. That is probably the quickest way from just a second, or create the file manually, but configure is probably the easiest. Yeah, basically run AWS configure in your terminal. It will ask for your access key, secret key, and the default regions. What that will do is basically populate a config file that's in your home directory in a hidden folder, .aws. And basically all your configuration is stored there, which you can then edit manually afterwards. and with that configured, all of the other CLI tools should work.
And
Oh, it's specifically Spot.
Yeah, and then there's a question from Dmitry regarding the.
Yeah, I
Yeah, so
just
bless you.
realized that. Thank you.
Yeah, it's now a difficult time. It's of sneezing. Hopefully nothing wrong. So we have a question from Dmitry regarding the Spot web user interface about the IAM authorization data. Can you show it once again? I think you should.
Yeah, I showed that, but the problem is that I realized what the problem is, and that's we didn't actually give console access to the attendees, which means it has to be done through CloudFormation, through the CLI. So that is a bit of a mess up from my side, but I think you can actually pull the config from it gives you the template, and then you can apply it through CLI, but maybe I can again get it. We can do that after we finish the workshop, and we can do it one-on-one, because from top of my head I don't remember how to do it through the CLI side.
Great. Yeah. Then yeah. Let's do that. And is it okay with you? Like if I say that maybe the quickest way to get to you is through the Slack in the AWS community channel?
Definitely.
Okay. Yeah. So I'll share the link to the Slack channel once again with everybody. And then Dmitry, you can find Klaus there, and you maybe.
Yeah. Sorry about that. That is totally my bad, because it's totally possible to do it through the CLI as well. I just haven't worked with CloudFormation through directly CLI without using something like Terraform directly. So, right, then back to doing things. Right, so as we can now see, what's happening here is that the cluster has been registered on the side of Ocean, and as it scales, it will start to take over the existing pods, or rather, it will start to start up instances on its own, and at the same time, it's not actually touching the existing ones at the moment, but as new instances spin up, it's going to all be already on the Spot infrastructure. What we can do is make a migration where the older instances will be terminated, but that's just to show as an example, because it's a process that again takes a while, because for all the older pods, it does so to ensure uptime, so you're not losing any uptime at any point in the process, and that's why it takes a while to migrate. But once that's done, and once new pods are spinning up, it's already all just run on Spot. But once the migration is done, it will automatically terminate the old instances. So ones that are started up with the auto-scaling group created by EKS CTL, and instead using this Ocean logic behind it. Now, to see some form of, again, scaling, what we can do is basically force our hand in regards to the scale. And to do that, we can run kubectl, edit, deployment frontend. Which opens up the configuration and description of the front-end application. And what we can do is basically force the scaling instantly by inserting in the spec that we want 40 replicas. Once that's closed, we should instantly see the action happening. And while it's starting up, if it's gonna be actually pounding enough pressure, it should force Spot side to already pick up new nodes, which are for now just simply the older ones, but I guess it's not enough pressure. Because some are already being scaled and downscaled. And all of them are in the same IP. Right, because during the migration, it's still routing through that. So it's gonna take a while it migrates, but it shouldn't really matter because the visual in that regard doesn't change. It just simply takes a while to spin up those instances, but while once this is complete, which will simply not wait around because it takes too long, you'll be able to see all the cost information and cost analysis over time. So it will actually show what's costing with fairly good details, and the constant node availability changes. And there's any kind of activities are constantly logged, and that's always available to see. And over time, as you're using the cluster more, you'll see right sizing information. So it actually will give you detailed information of why it's using what kind of instances. One of the other things that you can actually do is also customize scaling. And by default, there's a thing called headroom enabled. And what headroom is basically kind of literally headroom that you're constantly affording. Basically, it's the overhead that you're giving the cluster in regards to power. So that means that no matter how you're scaling or what the size is, that amount of percentage will always be left ahead. So that's mainly for events if you have sudden burst loads. So you get a large amount of external access or whatever kind of activity that would generate large amounts of load. You can account for that by specifying the headroom. And you can also change things like how much of the cluster is scaled at a time. for dev environments, you can actually enable it that it's only up for certain times of the day, which is also one of the cooler things, which I think nowadays you can actually do in AWS as well, but for the longest time that was a fairly annoying problem to deal with while running scaling, proper scaling, and turning off dev environments during weekends or off hours. Whew. Right. And specifically to Ocean, you also get a couple of other nifty features, which comes back to the question of how is it better, is that you can specify certain scaling aspects, not through AWS or Spot, but Kubernetes directly by specifying in your application specification. You can actually give specifications like you want these pods to be only on that specific availability zone or that specific country or overall bigger zone and that kind of stuff. You can also specify, you can also specify instance types. So that, for instance, you have dedicated instances to that specific pod. So for instance, if you have high CPU pressure kind of, or high memory bandwidth dependent applications running, or basically anything that would depend on specific hardware, you can force that pod to always run on specifically one kind of instance. And the way it's added is with again simply adding a couple of topology like descriptions in your application descriptions. I'll swap it to code. So yeah, the important part is basically simply these couple of lines. So this example is for availability zone. So you specified that you want it specifically in EU West 1B. So this specific pod then would always be picked up only in that specific availability zone. You have others where is you can specify the life cycles and here we go. Yeah, and again with the affinity part, you can specify the instances, and there's various other configurations that you can run in specifically to Spot scaling, Spot Ocean scaling. And you can also have various different kind of these specifications running in parallel as well, which is also, I mean, not really unique to Spot, but combined with these kind of advanced configurations, it does give some kind of benefits as well. yeah, as you can see, or well, no, since I turned it off. As you can see, and the migration itself takes a while, which is not inherently a bad thing since you'll be doing that only once. But that means that we can't show some of the features just yet. Or well, I guess today at all, since this is gonna take around an hour. But it's something that you can do and test on your own afterwards if anybody wants to play around like you, Dimitri, then I'll basically help out setting up the Spot integration afterwards through Slack. But yeah, with that, and that's pretty much it. So the complication of having an auto-scaling Kubernetes cluster that's running on Spot instances, it's basically as simple as starting up a cluster, which can actually be done directly through Ocean as well. You don't even have to do it through EKS CTL, but that's just an example of how easy it is to even bring over existing infrastructure as well. And specifically for Spot.io, like Ocean is just one of the options how you can use it. And I guess Ocean specifically is the coolest in the regard for the amount of time it saves, but they also run a similar thing for basic auto scaling groups as well, where you can set up Spot managed auto scaling groups of basic EC2 instances without the Kubernetes on top in case you have some dedicated applications running. Or one of the better use cases is if you have something that really needs a lot of power, but the cost of that would be a bit out of bounds. And normally through Spot, you can basically manage to run that without spending time configuring auto scaling that much. And to answer the costs per cluster, in the case of EKS, EKS on its own, I think costs around $70 simply for per month for the management side of things, since that is what EKS runs. They run the management nodes, and for Spot side of things, I guess Julius will actually go over that.
Yeah, I have a slide for that, Martin. So just bear with me. Klaus, is there anything else you would like to add?
I would say, like, from the most things, that is the general overview. Like, think about questions that you might have, and if there's anything that I've seemed to have glossed over and not in enough detail, then just post it and I'll go over it. But in the meantime, yeah, maybe you can go over the pricing slides.
Yeah, sure. I also wanted to ask your own opinion. While preparing for the workshop, as far as I understand, you got to know the platform a lot better than before. So what's your experience and opinion now once you got to know the product?
I've used this a bit personally as well before working for the workshop, and more specifically the auto scaling groups, but I did test out clustering, and I would say it's pretty neat. It's definitely, in my opinion, it's better than the AWS built-in management for it, simply because you get more control over it, and the integration between Spot and automation tools is, I would, in some regards, better than the stock AWS ones.
Okay. Yeah. So that's as I mentioned in the intro, that is similar to what I've heard from most of the other customers that are using Spot that I've spoken to over the years. Okay, so I see no more questions at the moment. If there are any, yeah, just shoot them here. We'll answer them, or we can always do that via Slack. Actually, there are like even people from AWS there, so then it would be interesting to hear their own opinion. Though actually, even from people from AWS, I've heard a lot of good things about Spot, as they're like technology partner with AWS, and they're very closely in very close relationship. Okay, so yeah, the very end, I wanted to go over like the business side of the things, because yeah, the natural question you have, okay, maybe I like it, maybe I don't, but how much does it cost? And if you haven't checked that already, so Spot platform is completely free actually for up to 20 instances. And yeah, 20, that's really a lot. So that's the reason why a big part of for example, CloudWather customers that are using Spot, they're not paying anything for the platform itself, and which is pretty cool, I would say. And once you grow on either higher level of SLA and support, it is priced on the basis of the money you are saving. So that answers the question like of how much the cluster costs. So it basically depends on how much your Spot instances are like cost you, and which that varies bit by bit depending on what kind of instances you're running on what region. But overall, at least Spot says that you could be saving from 70 to 90% of the spend in comparison to on demand, and then 28% of what you save then goes to Spot as a fee for the platform, which I think is in my humble opinion, it seems like a very reasonable approach, and like a win-win situation. And if that's not enough, we agreed with Spot that the attendees of this workshop are eligible for a special offer to get 10% off your spending for Spot platform. So if you would like to use this offer, just anytime, like now, tomorrow, or like anytime till the end of the year, just reach out to us via the emails that you got while registering to the event, or just directly to me. Here are my contacts. So then from my side, if we're closing things because I don't see additional questions, I think please go ahead and give Spot a try. I'm sure you'll be very pleasantly surprised by how cool it is. And then in the meantime, I want to thank first of all, of course, Klaus for taking the time and preparing for the workshop, and all of you for taking the time to listen to what he and I had to show and say today. And we're looking forward to meeting you in the other CloudWiser events. And Klaus, do you have anything else to add?
Well, mainly that, yeah, so already Dimitri wrote me on Slack, basically, if anybody else wants to try out this on your own time as well later, then the accounts can be still left open for a couple of days, and I'll write me on Slack. I'll help you set up the authentication part through the CLI, or we'll get you console access for that.
Okay. So as we answered all the questions, went through the whole workflow. So then I guess, Klaus, we can maybe say goodbye to everybody and then like just say goodbye. What do you say?
Yeah, I guess we can call it.
Call it a day. So then thanks again, everyone. And please also fill the survey that that just popped up in your screen. You know, your feedback is very much appreciated, and it really helps us a lot on the next events we'll be doing for the AWS community in the Baltics. And in the meantime, thanks a lot, and see you soon, hopefully.
All right. Have a good day.